Another specialization is anonymity or privacy-related developments. So we already discussed the previous one, the scaling, for example. In this case, this is equally important because anonymity / privacy tools prevent, for example, mass surveillance and can secure certain parts of freedom of interaction and being whoever you want to be. Because as you know, we can record multiple things on the blockchain other than currencies. So the problem here, though, is that it's quite difficult to understand. These cryptographic techniques are only understood by a few and therefore are very hard to not only implement but to explain and to look beyond the implications when you build something. So it's very hard to create decent peer-to-peer communities, and sometimes another problem kicks in because one scientist or researcher believes in that route and another one believes in that route. Luckily we have forks and we work in open source environments, so everybody learns from each other's mistakes. But it's of the utmost important that not only we get the scale, but also that we actually enable privacy-related currencies in this case, or other types of data. So what are examples of projects? Let's take Monero, for example. We typed down how Monero works, but to explain it in short is that they work with two components. Component 1 is the ring signatures and component 2 are stealth addresses. And without getting too nitty-gritty and mumbo-jumbo stylish on you, is that the ring signatures is where Bitcoin connects the input with the output. A ring signature grabs all the different inputs in a block, then puts them in a sort of a ring, just see them as a laundry washer mixing them up, and then throws them again to their desired output. But not only can't you relate anymore the input, so which input goes to what output, but also the second component, the stealth addresses, are at the output side. So you don't know who the recipient is. So you can see where the money originally comes from, but you don't know where it goes to, and neither do you know which amount goes to whom because of the ring, the mixer. If you want to learn more about it, just watch the further readings. But this is just one example of how you can fix more privacy-related stuff in a open public blockchain. So Monero is just another example. A more common version that you see are the snarks or the ZK-snarks technology, and those are equally difficult. To really simplify it, I always use the most famous example there is regarding ZK-snarks. This is also known as the Alibaba cave, where I think Alibaba is here. And this is a cave where here there is a, let's name this thing, a wall. And Ali needs to prove that he is the owner of the key for this door. So how can he prove this? Somebody is here with him. Let's call that person XYZ. Like that. So person XYZ. Ali needs to prove to person XYZ that he knows this information without revealing it. So you can either, for example, show your identity without revealing your real identity. So let's say that you want to go into a club and a bouncer asks for your identification. You don't give away your identification, but you do prove that you're older than 21, for example. So how do you do this? How can you give away a certain amount of information without revealing all the entire information? Well, welcome to the Alibaba cave. Let's say that you have two routes. Route B in this case, or exit B, that's this side, then you come back from this side of the cave, and this is route A. So I can imagine that you don't fully understand this version. So you need to go inside the cave, and as soon as you get into the cave, X, Y, Z says, okay, you need to come out from side B or from side A. So you either have two options, side A or side B. So you either walk like this, or sorry, what you need to do is walk towards here, and then XYZ says, okay, I want to know, I want to see you exit via side A or B. And then you come either from this side when XYZ says A, so then you need to unlock the door, because otherwise you can't pass. And if XYZ says, okay, I want to see you exit from side B, then you just walk back and you don't show the key. What XYZ doesn't know is where you stand. So XYZ doesn't know whether you are here or whether you are here. What XYZ can do is not only ask you once, because then you might get lucky. So if you picked route B and XYZ claims B, you just walk back without revealing the code. That would be a lucky shot. So XYZ doesn't ask you just once, but think in ZK-snarks like, well, let's say for example 2,000 times. Of course, 0.50% till 2000 is quite a slim chance of you succeeding 2,000 times proving or picking the right angle before XYZ asks you that. So, you might have lost me, or I might have lost you here. What you need to know from here is that you reveal an information. So you reveal that you came from A or B without revealing where you are. So you reveal some part of information without giving away your core route, your core element. So it doesn't matter, you can prove, you can show for A, you can show for B. It doesn't matter what X, Y, Z asks of you. If you know the code, you can produce both. And X, Y, Z will never know who's whom. So those are ZK-snarks. You can apply them, for example, as mentioned before, in when you need to prove something, for example, when you want to enter a club or something, or when somebody I don't know, if you get a traffic jam or a traffic ticket or such. Other than that, there are many more difficult cryptographic functions. We summed, and projects, we summed a few of them, or we found a few articles that compare them quite well. So think, for example, Zcash implements ZK-snarks, Monero does the ring signatures, we've got Dash, who's working with some sort of new consensus stake algorithm. There was some side note though that Dash wasn't all that anonymous. So those stuff only pops up when when an expert looks at these projects. What for me a valid sign is that often when a system gets hacked, nowadays they don't often ask Bitcoin anymore, so they often move, for example, towards Monero, which I think at the moment is one of the more stable and most anonymous currencies. Hence explaining why, of course, the hackers or the black hat or dark hat hackers move via Monero. Final note, recap with the other content that I just learned you as well, or that just taught you as well, is that even though Bitcoin, for example, is pseudo-anonymous, via sidechains and atomic swaps, you can connect with these types of blockchains, let's say, for example, Monero and Bitcoin, and then you have increased anonymity, but the robustness of, in this case, a Bitcoin network. Interoperability, beautiful as well. So we have multiple things to discuss. As mentioned, we will gradually add more content and topics that regard these privacy or other development-related content. So for now, you know more than enough for your economical deep dive. We will see you further in week 2, where we will finally discuss token economics and how to arrange and incentivize ecosystems. Take a rest for now. Enjoy that you've learned a lot about innovations and about blockchain innovations. Good luck with your test this week, and we will see you next week.